Hey everybody, so today we're going to talk about experimental probability. So you may be able to tell just from looking at the name that experimental probability involves running experiments. So let's take a look. So when we talked about theoretical probability, we said that that was the chance that something should happen. With experimental probability, this is the chance that something actually does happen when you try it out. To find experimental probability of an event, you actually have to test it. Then you will write the number of times you get what you want over the total number of times you try. So for example here, the probability of an event, the experimental probability of an event, is the number of wanted outcomes over the number of tries. As a fraction, that's how we'll be writing it in my class, but you can also change it to a decimal or to a percent. We have a few experiments we're going to run here in this video. So first, we're going to roll a die 10 times, and we are going to find the probability of getting a 2. After running our experiment, we didn't roll a 2 one single time out of 10 tries. So that means the experimental probability here was 0 out of 10. Now that of course doesn't mean that there aren't any 2's on that die. That just means that when we rolled, we never got one. The more often you run an experiment, though, the more likely you should get something closer to the theoretical probability. So if we were to run that test, let's say 1,000 more times, we should get some sort of a probability that is equivalent or close to equivalent to 1 out of 6. Let's try another experiment. We're going to take a deck of cards. We're going to draw a random 5 cards out of the deck, and we're going to find the probability of getting a face card. All right, out of the 5 cards we drew, we got a face card twice. So that means that the experimental probability was a 2 out of 5. It doesn't want to write for some reason. 2 out of 5. All right. Let's clear the ink and let's do another experiment. In my class, I have something I like to call the bucket of chance. In this bucket, I have poker chips. I have red, yellow, blue, and white chips, and I have an equal number of all 4 of those colors. We're going to draw 20 random chips, and then we're going to make sure to replace each chip after we draw it. That keeps this experiment independent. And then we're going to record whatever we drew, and we're going to state the probability of getting each of these different things. So let's run the experiment first. All right, after drawing the chips, we found that we pulled a blue chip 4 out of 20 times, or, because remember, we like to simplify, 1 out of 5. We drew a red chip 8 out of 20 times, which would simplify to 2/5. We drew a yellow chip 4 out of 20 times, which is also 1/5. We drew a white chip 4 out of 20 times, now these are just the different color chips that we have, and it's interesting that a blue, yellow, and a white chip occurred evenly. All right, there was they came out equal, which is what should happen. The number of red chips that we drew was much more frequent. The probability was much higher than it really should be. It was double all the other chips. Now that does not prove that there are twice as many red chips in that bucket as there are blue, yellow, or white. That's just the outcome that we got when we ran this experiment. The more often we do the experiment, the closer our probabilities should get to being equivalent to a 1/4. All right, how about the red and the white chip combined? So to do that, we would just add up the number of red chips and the number of white chips we got, and let's go with our simplified fractions. And so we got a red and a white 3 out of 5 times, a red or a white 3 out of 5 times. Non-yellow chips, this is pretty simple. So if 1/5 of the chips were yellow, all the rest of them were not yellow. So we could just subtract 1/5 from 5/5, which would represent 100%, to find that 4/5 are not yellow. Okay, that's it for experimental probability. Thank you very much.